Hey guys, this is lesson 6.3, graphing radical functions. So first let's just briefly describe what a radical function is. And it's a function that contains a radical expression with the independent variable in the radicand. So the independent variable for us is usually x, and being in the radicand means that it is under the radical symbol. All right, so for example, over here on the left, we have a square root function. So our square root function, this is what the parent function graph looks like. All right, for f of x is equal to square root of x. How do I know this is a square root? Because if it doesn't have a little floating number out here, then it's considered a square root. You could go ahead and write the 2 there if you wanted to, if that helps you remember that it is a square root. But it's not typically written. It's one of those implied things, kind of like ones in front of x's as a coefficient. All right, so let's talk about the graph. You'll notice that the graph starts at 0, 0, and it continues kind of up and to the right. So it's going towards positive infinity in the x and the y direction. So the graph, the square root graph, starts at 0, 0. And because it doesn't have any negatives, it doesn't have any negative x's, negative y's, our domain for this graph, x, remember domain is always x values, is going to be greater than or equal to 0. So it starts at 0 and it gets bigger. The same thing with our range. Our range starts at a y value of 0 and it increases. Just to remind you, range, when we read from left to right on our graph, that's actually our domain, our x values. And when we read from bottom to top, that's our range or our y values. All right. Now, our square root function can be transformed, and when it's transformed, if the whole function gets moved up or down or left or right from a transformation, then that can change our domain and range because it's moved our starting point. So let's just kind of summarize that. So transformations, which we're going to talk about in a minute, transformations can change the domain and the range, the D and the R. And that is because we are moving the starting point. Since we have a distinctive starting point, if we transform the function by shifting it up, down, left, or right, that changes our domain and range. Now, let's look at a cube root parent function. So the cubed root parent function is the cubed root of x. How do we know it's a cubed root? It's got a 3 here as the floating number in front of x. Remember, that's called the index, that floating number. Now, if we move this parent function up, down, left, or right, this kind of center point here at 0, 0 is going to move. However, you'll notice that this graph goes as far as you can think to the left, as far as you can think to the right, and eventually, even though it's not real steep, it is going to go to positive and negative infinity in the y direction as well. So our domain here is all real numbers, and so is our range. And a transformation, just by shifting that center point, not a starting point, but a center point, up, down, left, or right, that's not going to change it. Okay, so transformations do not change our D and our R, our domain and our range, when we are talking about a cubic function, because our domain and range to start with is all real numbers. And so that doesn't change by just shifting that center point. All right. So let's talk about the things that will change our graph in general. We can do transformations just like we have done multiple times before. We talked about transforming constant functions, linear functions, absolute value functions, um, quadratic functions or functions where we had an x squared, cubic functions most recently, and now we're looking at square root or cubed root functions. So just like we've done in the past, we're going to look at those translations and transformations. So remember that when we are adjusting something horizontally, it's kind of the opposite of what you would think. We're inside with x, and negative takes us to the right. Positive moves us left. Again, inside with our x, and that is opposite. What do I mean by inside? In this case, it means under the radical symbol. All right, vertical translations are outside. Notice that these are outside. They're not under the radical. Positive moves up and negative moves down. Our reflections are just like they've been in the past. If we are inside with x, that's a horizontal reflection. We're reflecting across the y-axis and affecting our horizontal values. So again, inside with x, if you see a negative sign, it's reflecting across y. A negative sign on the outside is outside. It's reflecting across the x-axis and changing our y values. Stretches and shrinks are just like they've been in the past. Horizontal is opposite. Remember, it's the reciprocal because we are inside, and inside is opposite. So a 3 on the inside is actually a shrink by 1/3. A 1/2 on the inside is a stretch by 2. And finally, vertical stretches and shrinks are more like we would think they are. The big numbers stretch us, and the smaller numbers, the fractions, are a shrink. All right, so what we want to do is we are going to describe transformations, just like we've done multiple times before. Then once we describe our transformations that we've done to our parent function, we're going to go ahead and graph the function and talk briefly about our domain and range and how that might have changed or not changed depending on the transformations that we have done. All right, so we are going to do some examples where we describe the transformation that's happened and then graph the function, our new function g of x, and state the domain and range for that new function. We know our domain and range for our basic parent functions that we just talked about up there at the top of the page. All right, so for example number 1, I'm going to change colors here actually. Example number 1, my f of x, my starting point, is just going to be the basic square root function, square root of x. And g of x, my transformed function, is x minus 3, all under the radical, and then plus 4 outside the radical. So let's take a look at what we've done to this. Inside with x, we have a minus 3. Remember, inside is horizontal and opposite. So horizontal translation, right 3. Next, the 4 on the outside is a vertical translation. And that's going to be up, positive, by 4. All right, so let's go ahead and jump over to Desmos real quick. I want to show you what the original parent function versus the transformed function look like, and then we're going to come back and graph those. You can do this in Desmos when you're doing your homework at home. Remember that Desmos is built right into the Big Ideas Math. It's down in the lower right corner. In class, I suggest that you use your calculator to get some practice using the calculator because that's what you're going to have on a quiz or a test. All right, so just go ahead and graph your function. Take a look at what the graph looks like. You can even jump to the table if you need to see some of the values. All right, so let's look at Desmos. And for example 1 here, my original parent function f of x is equal to square root of x is there in red. And you can see my transformed function is in blue. And notice that it has moved over by 3 to the right and up by 4 to the left. And that is exactly what we expected based on the transformations that we described. It has not stretched or shrunk. It hasn't gotten closer to the y-axis, and become a more rounded curve. It hasn't become a flatter curve either and gotten closer to the to horizontal. All right. So let's go ahead and go back and graph that. All right. So we know that we're kind of over here in quadrant 1. So I'm just going to kind of draw quadrant 1 here. And we said that we went over 3 and up 4 to our starting point now. So over 3 and up 4 is here. And then we have kind of a sideways half parabola is how I kind of describe a square root function. So that's 0.3 comma 4. So that means that our domain and our range have both changed because our domain now starts at 3 instead of 0. So it's going to be x greater than or equal to 3. And our range, our y value, now starts at 4 and goes up from there. So it's going to be greater than or equal to 4. So because we have moved up, down, left, right, our domain and our range have been affected. All right. Let's look at another example. We're going to look at a cubic function this time. So our f of x is going to be the cubed root of x, and g of x is going to be the cubed root of negative 8x. All right, so let's look at the changes that we have made. Remember that a negative is a separate transformation all by itself. All right, so that negative sign inside with x, it's under the radical with x, means that it's changing horizontal numbers, so it's got to be reflecting over the y. Whoops, over y. The 8, again, inside with x, is going to be opposite of what you would normally think. So that's a horizontal shrink by 1/8. Remember that it's the reciprocal when we are inside with x. All right, so let's take a look at what our graph for that is going to look like. We're expecting it to flip across the y-axis. So our S shape is going to be kind of the opposite of our parent function. And we're also expecting a horizontal shrink. So we're expecting it to shrink away from the horizontal axis and more towards the vertical. So let's take a look at what that's going to look like. So example 2. All right, here we go. Again, red is our original and blue is our new. And you'll notice that the blue one looks a little fatter. It's gotten further away from the horizontal axis. It's shrinking away from the horizontal axis. And also notice that the shape of our S curve has completely flipped around. To pick a point out, the 0, 0 point is still good. Okay, well, 0, 0 right there. A point that used to be here on the graph at 1, 1 has now moved to negative 1, 2. So that's because of the shrink away from the horizontal axis. All right, let's go back to our notes and graph and talk about domain and range. All right, so back over here on our notes, let's go ahead and draw ourselves an XY grid here. And I know that I'm still going through point 0, 0. I didn't move my center point because I haven't translated up, down, left, or right. And I was able to pick out that point -1, 2, and we'd have kind of an opposite point here. If you just wanted to be a little more accurate with your graph, you could put those points on there. And our graph is going to look something like this. Still kind of an S shape, but it's gotten a little fatter. Mine's not looking so good. Hopefully you can draw an S shape a little better than that. But my center point is at 0, 0. Domain and range, this is a cubic function, and we said that those are never going to change. So domain is all real numbers and range is all real numbers. All right, let's look at another one. This time we're going to go back to looking at a square root function. So f of x is square root of x, our basic parent function, and g of x is now equal to -2 times the square root of x plus 1. So let's break down our transformations. All right, so we have a negative here, which it's on the outside. It's outside, not inside the radical with x. So that's going to reflect over the x-axis. The next thing I come to is this 2, again on the outside. That affects vertical. So this is a vertical stretch by 2. Finally, followed by a +1 on the inside. So it's inside the radical with x, which means it's affecting horizontal. So horizontal translation, left. Because it's positive, it's going to the left by 1. All right, so reflecting over x, that means that our shape that was kind of a half a parabola up above the x-axis is now going to be below the x-axis. We're stretching vertically, so we're getting closer to the vertical axis, so it seems like it's going to be a little fatter. And then we've translated left by 1. We haven't moved up or down, but we have translated left by 1. So let's take a look at our graph. So our graph, example 3, again, our original parent function is in red and our new function is in blue. You can see that it is stretched a little towards the y-axis. It's kind of gotten a little fatter. We have translated over to the left by 1. Our point that was at 0, 0 here is now at -1, 0. And of course, we've done that reflection. So instead of going up towards positive infinity in the y direction, we're headed towards negative infinity. All right, so let's graph that. So we know we've got a point at 0, 0, or I'm sorry, at 0, -2, and a point at -1, 0 on our new graph. So let's go ahead and take care of that. All right, so our graph is going to look something like this. You know, we're kind of going down. We had a point at -1, 0. That's our starting point now. And we did cross the y-axis at -2. So our graph looks something like this. All right. Let's talk domain and range. Our domain has changed because we have shifted our graph. So now our domain is x is greater than or equal to -1. We have not moved up or down though, so our y is still going to start at 0, but this time because we're reflected, we're not headed towards positive infinity. We're not greater than 0. We're less than 0 always. So we're going to be less than or equal to 0 for our range. All right, let's look at one final problem. And this one, just to change it up a little bit, I'm going to show you how to write these when they are in exponent form. So if it's in exponent form, like x to the 1/3, and g of x is equal to 1/3 of x to the 1/3 power minus 6. So we've been talking about things under radicals. So I want to go ahead and change this to my radical form from exponent form. And remember that we can switch back and forth between the two using one of our properties. And so we're going to use the rational exponent property to convert the exponent, because we want to change that to a radical, because that's how we know how to deal with things, is when they're under a radical. So if we use the rational exponent property, that says that our base is still here, but now our base becomes our radicand. Our denominator is the index, and the numerator is the power. Okay, we don't usually write that one, so this could be rewritten as just cubed root of x. All right, so let's change our g of x. Our 1/3 that's out there in front still stays as 1/3 out there in front. X to the 1/3 power, again, is the cubed root of x. And then we have a minus 6 that's outside of the exponent. It's not like in parentheses with x, so it's outside, so we will keep it outside. All right, so let's take a look at our actual transformations now. We've got a 1/3 out here in front, so it's outside of the radical, so that means it's going to be vertical. When we're vertical, fractions shrink, so we have a shrink by 1/3. Shrink by 1/3. And then the other thing that we have done from our parent function is we have this minus 6 outside the radical. It's just kind of hanging out there in the back. So that means it's a vertical translation, because it is not inside with x. And that's going to go down by 6. Negative 6 sends us down. All right, so we have shrunk vertically by 1/3. That means that our graph is going to start becoming more horizontal. It's not going to be quite as fat. And then our center point in this case has moved from 0 in the y direction down to negative 6. So let's take a look at what that looks like on Desmos. Go to our last example, example 4. Again, parent function in red and transformed function in blue. You can see that it is a much flatter graph. It's not nearly as fat, if you will, as our original one. And so that has changed by a factor of a horizontal shrink by 1/3. And you can see that our starting point, or our center point in this case, has moved from 0, 0 down to 0, negative 6, just as we expected, a translation down by 6. All right, so let's graph that and talk about domain and range. All right, so back to our graph. We know we're down low here, so I'm going to give myself some room in the negative y direction. And we said that our center point was down at negative 6. And we have a fairly flat graph. So it's still kind of an S shape, but it's pretty flat here. Something like that. And again, our center point being 0, comma, -6. All right, we have a cubed root function, or a 1/3 exponent, and our original domain and range was all real numbers, and that doesn't change just by moving our center point, or by shrinking or expanding our graph, shrinking or stretching. So our domain is still all real numbers, and our range is still all real numbers. It's going to take us longer to get to positive and negative infinity in the y direction. Our graph is much flatter, but eventually, if you go far enough in the x and y, or in the x direction, left and right, you'll get there. All right, so again, when you have a cubed root function, domain and range never change. They are always all real numbers. All right, that's it. Thanks, guys.